we had the statement P that the what is it? The language is regular. It's regular, therefore it has a DFA, and if you have a DFA you can convert it into a GNFA, and from that you can get the regular expression. Therefore, if the language is regular, right to the end, you can get a regular expression. Okay? There's a chain of logic there. Hope you followed it, right? So now we given that sort of how many steps? 1, 2, 3, 4, right? 4 stages in this proof. So now we're going to concentrate on how to get from the DFA to the GNFA. Right? That's what we'll concentrate on now. So first need to explain what a GNFA is, right? And then we can talk about how to convert a DFA into a GNFA, right? Okay, so first show how to convert the DFA into a GNFA, and then, like the next step, then how do you convert a GNFA into regular expressions? All right, what is a GNFA? Well, it's an NFA, not surprising, but generalized, not surprising. But in what sense is it generalized? Well, the essential difference between a GNFA and an NFA is that, as I was saying earlier, earlier session, that with a GNFA, along the transition arrows, you can have more than just an input symbol. I mean, you can have an input symbol, but you can also have regular expressions. Right? So here's an example. Here is a GNFA, an example of one. Okay. Now it looks pretty much like an NFA, right? It's got a start state, and well, in this case it has one accept state, and it has other states, and it has transition arrows, right? Now here's an example of a transition from this state to this state with just one symbol. Okay, so in that sense, this transition arrow here is what you're accustomed to with an NFA. But here, you've got regular expressions. Okay, so if you see that side of this kind of thing, and if the labels on your transition arrows, if those labels are regular expressions, I mean complicated regular expressions. I mean this is a regular expression, but more complex regular expressions, then you know that this automaton is a GNFA, a generalized. Right? Generalized in the sense that you can have more complex regular expressions as labels on the transition arrows. Okay, so that is an example of GNFA. Now we're just scratching the surface. Now we need to go into quite a bit more detail about what a GNFA is, but that'll give you something to stew on, think about. That's your first taste of a GNFA. Alright, now how does it work? Well, it's an automaton, right? So it's reading in input strings. So, and it too will transition from one state to another, but when? Well, after it's read a block of, or if you like, when it's read a substring, like a block of input symbols, contiguous together, so like a substring, if you like. And if that substring matches the regular expression, is compatible with the regular expression, that is a label on a transition arrow, then the next state will be, like, for example, say you're in the start state here, and you read a block of the input string, like you read a substring that's compatible with A, B star. So say you imagine you read A, B, B, B. Okay, well that's compatible with that. So you transition to this state. Okay, now it's an NFA, right? So so now you're in this state, and now imagine you read AA. Well, you loop back to the same state, or oh, wait a minute. Well, it's an NFA. Now you have. Now that's interesting. I haven't seen that before. This AA is compatible with A star, right? So you could go back to this way, or you could go to here. Now that's characteristic of a GNFA. So it's non-deterministic, right? So it can process the input, the substring that it's reading, in several different ways. And here's an example: loop back to this state, or take this route, this transition arrow, to this state. All right. Now how? So effectively, to get from one state to the next, you're reading a block of your input string, like a substring, okay? And then, and if you read a block that corresponds to the label on a transition arrow, well then you transition to the next state, the state that the arrow points to. Now, how does it work? Like, how does it? It's an NFA. It's a generalized NFA, but it's still an NFA. So how does it stop? Like, how does it accept or reject? Well, that's the same, pretty much. If when the input string has finished, you've read the last symbol. If the state that you are in is an accept state, then that GNFA accepts that string, right? So that's pretty much the same as the NFA that you're used to. Okay, so that's what it's saying here. So the input string gets accepted by this GNFA if it's in the accept state. Its final state, if you like, is the accept state after the input string's ended once it's read in. All right, now. So that sort of gives you an overview of what a GNFA, but there are complications. To make the use of a GNFA useful, to make it convenient, there are certain restrictions, properties, constraints, if you like, put on this GNFA that are very helpful. They make things. They make this GNFA much easier to use. Okay, and Sipser lists 3 of them, and I've got 2 here on this session. Now the third one, like this star circle. I mean, I could put 1, 2, 3. Now the third one is like starts on the 4th line of the next session. You won't see it, but I'll read it out to you for the sense of completeness. Now, so what I'm going to do now is give you 3 properties, 3 constraints, 3 things that help make the use of a GNFA easier. Make it, well, so it works. so that once you've got your GNFA, you're then able to use it. And by imposing these 3 conditions, these 3 constraints, then you can then use that GNFA to generate the regular expression. Right? So you need these 3 constraints, right? So I'll read them out and then sort of point at an example of the constraint on this this example here of a GNFA. Right. So the first one concerns the start state here, and it's saying this start state has transition arrows to every other state. Okay. So from here, there will be transition arrows to all the other states. So there'll be an arrow to that one, well there it is. There'll be an arrow to this one, there it is. And there'll be an arrow to that one, there it is. So your start state points, if you like, has transition arrows to all the other states. Okay? So mental note. Yeah? So this has, here's your start state,